Okay, we're going to talk about the second part of 16.1, the area of a circle. We're going to justify and apply the area formula for circle, which you guys know area equals pi r squared. All right, let's look at it. So in particular, we're going to be looking at this particular task from illustrative mathematics, and we're going to look at parts A and B. So we're going to first figure out a way to write the area formula of an octagon in terms of its perimeter, and then we're going to use that formula to go ahead and explain how the area turns out to be pi r squared. All right. So we're going to be picking up really where we left off. We have this octagon that's inscribed in a circle, and we're going to go ahead and look at, this interior angle here. And we said last time that this is 45, and you'll remember that it was 360 divided by 8, and that's how we got 45. Now you'll remember that all of these lengths here are little radii, and so that creates all these little triangles, so 8 triangles. And the radii, of course, are all congruent. So I would say that all 8 of these triangles are going to be congruent, and they're going to be congruent by side angle side. So I'm going to say all 8 triangles are congruent by side angle side congruence theorem. Now last time I said that all the 8 triangles were similar, and they are by angle similarity theorem, but they're also congruent. So this time we're going to use congruency. And so next, what I want to do is, so I'm going to go ahead and label this triangle here, and I'm going to say that this is the base like I did last time, so B, and then I'm going to say this length here would be the height. So I'm just going to put H for this length right here. So if I wanted to find the area of that particular triangle, so this triangle here, then I would just use my normal area of a triangle formula. So I would say area equals, and it would be 1/2 times the base, so that's B, conveniently. And then the height is H, so we would just say area equals 1/2 base times height. Now that would be the area just of one triangle. Now if I wanted to find the area of the whole polygon, or in this case octagon, let's say area of the octagon would be 8 times that, right? So I would say 8 times 1/2 base times height. Okay? Sorry, that B is a little messed up there. Okay, so all right, so now we have area of the octagon. What we want to do is write the area of the octagon in terms of the perimeter of the octagon. So what I want to do is I want to label each of these lengths as B all the way around. So wouldn't you agree if I wanted to find the perimeter of the octagon that it would just be 8 times B, just adding up all the outside lengths, so 8B. So if I sort of rewrite this area of the octagon formula that I have here, let me just kind of rewrite it. So area of the octagon is equal to, and I'm just going to rearrange it. So 8 times B, I'm just going to put that first. So that would be 8B, and then of course I would still have the 1/2 there, and then times the H. Okay? Now the 8B, of course, we just said is equal to the perimeter. So we can say the area of the octagon is equal to the perimeter, and then times our 1/2 H. All right. Now what happens is, and we saw this before, that whenever we increase the number of sides of the polygon that's inscribed in a circle, that polygon gets closer and closer to the actual circle. And so what we can say is that this really would suggest that it doesn't really matter, again, the size. So we're going to say that the area of the circle would be equal to the perimeter of the circle, which again is the circumference. So we're going to say circumference, and then that would be times 1/2. Now, instead of putting an h there, what happens is whenever when you have a greater number of polygons, this radius, instead of it being a radius, the radius ends up actually being super close to the radius. So if you can picture that radius pretty much, or the height of those little triangles, they turn out to be so close to the actual radius of the circle. So that's what happens. So it approaches the radius, those heights. So we would say circumference times 1/2 times the radius. So I'm going to go ahead and move to the next slide to have a little bit more space. So remember that. I'm going to go ahead and write that in the next spot. So we would say that, and I'll just put it on a blank sheet here. So I'm going to say that we have the area of a circle is equal to the circumference, and then we said 1 times 1/2, and then times r. Now we learned last time what the circumference of a circle is. So we would say area of a circle is equal to, and then we would say 2 pi r times 1/2 times the radius. So I'll leave out the area of a circle there. So area equals, and then we would see that the 2 times the 1/2 cancels out, and we would have pi r squared. So there you have it. So now let's go ahead and start applying the formula. So to a couple problems here. So it says, given the radius of the circle, find the area in terms of pi and to the nearest tenth. So here's our area formula. Area equals pi r squared. So we have area equals pi. The radius is given as 8 miles. So we put that in there, and then we square it. So area equals, and then we just square the 8. So that would be 64. And then we can put the pi next, and then we'd have miles squared, or square miles. And then it says to the nearest tenth. So let me figure out what that is. So then we would do 64 times, and just search for your pi button on your calculator. So area is approximately, that's our symbol for approximately, if we're rounding it. So 201 point, and I would round that to 1, so 0.1, and then that's square miles. Okay? Next problem, the area of the circle is given, so then we're supposed to figure out the radius. So I like to write the formula first. So area equals pi r squared. The area is 98 pi, and we could put our inches squared in there if we want, equals pi r squared. Okay, so if we're going to solve for r, we know we have to get rid of everything on that side. So we're going to go ahead and divide by pi. So that would give us, that would be r squared, and that would be 98, and that's inches squared. Then to solve for r, we have to get rid of the squared, so we're going to take the square root. So we take the square root of both sides, and we would have r is approximately, because I don't think square root of 98 is a perfect square, so we get approximately, and we round it, it would be 9 point, says round to the nearest tenth, so 9.9, and that would be inches. Now notice that was squared, and then we took the square root, so even the units, turn out to be just not squared anymore. So that's kind of cool to include the units. All right. The next one, we're given the area of the circle, and we have to figure out what the circumference is in terms of pi. So area of a circle, so let me just write the area formula. Area equals pi r squared. So the area is given as 25 pi inches squared, and then we have that equal to pi r squared. So let's solve for r. Let's find the radius first, and then we can try to figure out what the circumference is. So we're going to divide by pi on both sides. So that'll cancel out. So then we're going to have r squared, and that would be 25 inches squared. And then to get rid of the squared there, we're going to go ahead and take the square root of both sides. So then r is, this time it's equal because we can take the square root of 25. So it's a perfect square, so it's going to be 5 inches. Then we can come over here and figure out what the circumference is. So we can say circumference is equal to 2 pi times the radius. So circumference is 2 pi times this radius that we just figured out, which is 5 inches. And then we just multiply those two together, so that's 10 pi inches. And this one doesn't say to round it to the nearest tenth, it just says in terms of pi. So we're allowed to leave a pi in our answer there. I think that'll do it for us. Tiny bit of humor, and then good luck on your work this week.